Preparation of glycol. There are different ways of preparation of glycol. One is with KMnO4 and another one is OSO4. KMnO4 is popularly you maybe know, which is known as potassium permanganate, and OSO4 is the osmium tetroxide. First, we will get with the reaction with KMnO4. This is the alkane which react with potassium permanganate, which on hydrolysis we will get glycol. Let us see the mechanism. Here, alkene which react with the structure formula of KMnO4 is Mn with double bond O on the four directions. So here what happened? Look closely. Here the bond between the alkane breaks down and moves to the carbon. Okay, here the carbon and oxygen bond formations takes place, and here the bond move to the central atom, that is magnesium manganese, that is. So that what happened, as it goes to the here, as the this get here, so this bond breaks and comes to the here. To balance this reaction, here the oxygen gives us, means breaks the double bond and forms a negative sign here. As it done like this, so this carbon magnesium bond breaks down and carbon oxygen bond formations takes place, which means that the carbon carbon pi bond breaks down and carbon oxygen, two carbon oxygen bond formations takes place. If I will write it clearly, it looks like this: CH2 bond, CH2 bond O. You see, bond formation takes place, bond O, and that here bond O. Okay, here magnesium is there, single bond is present. Here one bond, as these bonds were broken out. Bond, like here, here what's happened? O, here bond breaks down and the electrons have to the negative sign. So here becomes O negative and here becomes double bond O as usual. Here what we get, 5-member transition state. See here, 1, 2, 3, 4, 5. Here I can write 5-member transition state. Okay. After this, here you can see water is added, which is on hydrolysis. So here what happened? The H2O, the water, which react with the magnesium. So what we, as it reacts with magnesium, it becomes 6-member. To make it constituents of 5-member, here the bond between the oxygen and the magnesium breaks down and it comes to the oxygen itself. So what we get is CH2 bond CH2. Here the bond is there between oxygen and bond O, as usual bond O. Magnesium is there, bond double bond O bond. Here water will add O, H and H. Okay, here as usual O negative is continued, and here the bond breaks down, so it will becomes O, as bonds takes place, so it becomes O negative. Okay, so as oxygen gives a lone pair to the magnesium, so what it becomes, positive side. As oxygen is more electronegative, so it want to be stable. So what happens here, one hydrogen from the oxygen, from the water, goes and gives an electron to the oxygen. So what here we get is minus H plus is, we will take it here, what we will get, that is CH2 bond CH2 bond O negative, bond O bond Mn double, sorry, bond O negative, double bond O, here OH will remain, comes OH. As H plus is there, OH minus is there, they will get forms a bond and we will get CH2 bond CH2 bond OH, bond O bond magnesium bond O negative, bond OH double bond O. So what here happens is the negative sign will come here and this double bond will go to the here. So what we will get, CH2 bond OH bond CH2 bond O bond magnesium bond O negative, as here O has given double bond O as convex bond OH. We will do this thing in the next page. We get this reaction in the previous page. So here again we come to the next page. So here this is the thing that we have seen in the previous page, and again hydrolysis will takes place and it will attack to the magnesium again. Okay, as it attacks to it, so this bond, now this bond will breaks down and comes to the oxygen. So what here becomes a CH2 bond CH2 bond OH bond O negative. As there is no connection between the magnesium, so here plus sign will come. Magnesium double bond O bond OH. Here water is added, bond O HH, and here will O negative. Sign comes here. Okay. Here as oxygen gives it to it, so it becomes positive. As oxygen is more electronegative, same we have seen the earlier in the previous page. As oxygen is more electronegative, so it wants to be stable. So one hydrogen atom will give to here, and what happens? Minus H plus sign here removes, but later on it will attach to the main component again. As negative sign is there, it will attack to the oxygen, becomes OH plus magnesium, and here what happens again? It goes there, and this comes to its original state. Bond OH double, sorry, O negative double bond O. This is the reaction for the preparation of glycol by using KMnO4.